All right, so our notes for angle pairs. We're going to talk about different kinds of angle pairs and how to figure out angle measurements and whatnot here with these specific angle pairs. These are new sets of vocabulary words that are going to be very, very important to make sure you add to your vocab list and are prepared for your vocabulary quiz. The first thing we're going to talk about is complementary angles. This is not new to you. Complementary angles are going to be two angles who have a sum of 90 degrees. Okay, so that sum of 90 degrees, they complement each other. All right, so how you may see this is just simply we have here a right angle, we know because of that right angle box, and then maybe a ray coming out where we don't need to give values, we don't need to give measurements because we have that 90 degree, that right angle box here telling us that these two angles are complementary angles, they add up to 90 degrees. But with complementary angles, you may also have two angles that are completely separate. So here, let's say this is 60 degrees, and then you could have another angle right here that we say is 30 degrees. They do not have to be connected. Okay, we'll learn what that means a little bit later. Then you have your supplementary angles. Your supplementary angles are going to be two angles who have a sum of 180 degrees. They supplement each other. So these are things that you need. These are the numbers, magic numbers, 90 and 180. Again, we could have this where we just have an angle drawn. We know that this is a straight angle, 180 degrees. And we just have another ray coming up, and I don't have to give any measurements. I know that it's a straight angle, or sorry, I know that they're supplementary because they add up to 180. Or again, they can be separated. So let's say that we had, this angle right here. Let's say it's 120 degrees, and then we had another smaller angle that, 180 minus that 20 is going to give you 60 degrees. So you can have them separated as well. Now there's a little tool that I like to use to help remember supplementary and complementary and which one's 90 and which one's 180. And what that is I draw a really big S for supplementary, okay? And supplementary S, we know is going to be, and I'm turning this sideways, 180 degrees. Well, if you cut that S in half like this, you see a C right here for complementary. Well, if you cut 180 in half, you're going to wind up with 90 degrees. So that's a little tool that I like to use to help out with which one's supplementary, which one's complementary, which one's 90, which one's 180. So let's go ahead and take a look at the first example here. We have angle 1, angle 2 are complements. So again, we have that complement. All right, so if you see that, we know that we need to be sticking with 90 degrees. Okay, so here this complements means 90 degrees. So they didn't draw the box in, but we know that we're going to have that right angle box. Measurement at angle 1 is 2x plus 20. So over here at angle 1, I'm going to go ahead and label it as 2x plus 20. Very important to label everything. I know I've told my students every day. Measurement at angle 2 is 3x plus 15. So let's go ahead and throw in 3x plus 15 over here. In the end, I'm going to want to find the measure of angle 1, which is going to be right here. So I'm going to substitute back in for that one. So because they add up to equal 90 degrees, we just simply say angle 1 plus angle 2. So we have the measurement at angle 1 plus the measurement of angle 2 is equal to 90 degrees. So we'll go ahead and substitute in. The measurement at angle 1 was 2x plus 20 plus the measurement at angle 2 was 3x plus 15, all equal to 90. This is where a lot of students struggle. We have to remember to combine our like terms. Okay, I see a lot of stuff going on over here on the left-hand side. I have more than two terms, which means I've got to combine some stuff here. Here I have my 2x. Over here I have a positive 3x. When I combine these two together, I'm going to wind up with a total of 5x's. And then I'm going to take a look over here, and I've got a positive 20 and a positive 15. So when I combine those two together, over here, we're going to wind up with plus 35. And this is all equal to, bring down that 90. So now we just have a two-step algebra problem. We need to get rid of the 35 next to 5x. So instead of adding, we need to subtract to cancel it out. What we do to one side, we do to the other. And 5x is going to equal 55. Last step here to find x, we're going to divide by 5. So they cancel out in front of the x, bring that x down. X is going to equal 11. Now going back, what do we want to find? We have to substitute in right here. So what I'm going to do is I'm going to take that x, I'm going to remove it, and we're going to plug in that what x was, which was 11, and continue on with that plus 20. And so this is going to end up equaling a total of 42 degrees. Sorry, I ran off a little bit. All right, so that's our final answer, what they were asking us to find. Take a look at the next one. We're seeing the symbol here. We are seeing that ray CD right here is, and this symbol right here means perpendicular to line AB. What does perpendicular mean? Well, we need to know what perpendicular means. It means it forms it intersects or forms a 90-degree angles. Now, when it's perpendicular, you're going to have a 90-degree angle on both sides. Okay? So let's continue reading through. We've got the measurement of angle 1. Here is 6x minus 3. So here's 6x minus 3. The measurement of angle 2 is 7x minus 11. So we have 7x minus 11. And we want to find the measurement of angle 2. So we're going to be substituting in for right here in the end. Again, we don't need to focus over here. What we have right here, angle ACD, is a 90-degree angle, a right angle, and we have two angles in there that are going to add to equal 90 degrees. So this is telling us we have complementary angles. So we're going to do the exact same thing. We're going to take our two different measurements. I'm going to leave out the math sentence this time. My angle 1, 6x minus 3, plus my angle 2, 7x minus 11, all equal to that complementary angle, 90 degrees. Let's combine our like terms. I have a 6x and I have a positive 7x. We combine those together. We're going to get 13x. And then now, don't get fooled here, we have a negative 3 and we have a negative 11. When you combine, that's like saying, combine means add, so it's negative 3 plus a negative 11. We're going to wind up with a negative 14. So when we plug it into the equation, we now have minus 14, all equal to 90. Two steps left here. Let's go ahead and add that 14 to both sides. So that on the left, we just bring down our 13x, the 14's cancel, and then the 90 plus the 14 is going to give you 104. Last step, divide both sides by 13. So 13's cancel, bring down that x. 104 divided by 13 is going to give us 8. Again, that's not what we wanted to find. So we have to take the measure of angle 2 right here, that's 7x minus 11. We need to remove x, okay, and we're going to plug in what x was, which was 8. And we plug this all into our calculator, we're going to find out that the measurement of angle 2 is 45 degrees. And what ends up happening is this actually is going to be an angle bisector, because if you divide 90 degrees by 2, it's going to be 45. So if you plug it into angle 1, you'll see it's also 45 degrees. All right? Next, we're going to talk about adjacent angles. This word, adjacent, is extremely important. You are going to hear it in geometry over and over and over again. You need to understand what adjacent means. This is two angles that share a common vertex and a side, but they have no common interior points. What this is, these are two angles next to each other, okay? They are touching right next to each other. So when we looked at the complementary and the supplementary angles right here, the adjacent angles were the two that were connected. So we have connected angles on this one. So adjacent angles can just look like this. We have two angles that share a common vertex and a side. So they're right next to each other. It's like whatever teacher you have, they share a wall with their adjacent coworker or adjacent teacher. They share that whole wall. So this is like one classroom, and here's the other classroom. Your non-adjacent is going to be the complete opposite, where it's just two angles, and we saw both of these with the supplementary and complementary, two angles that do not share that common side nor the common vertex. They do not touch each other at all. Okay? In example 4, we're going to go ahead and we are going to name a pair of complementary angles, a name of supplementary angles, and a pair of adjacent angles. Okay? So here what we want to do is we want to figure out, okay, what angles are going to add complementary angles, remembering that this is 90 degrees. We need to figure out what angles here add to 90. I don't see a right angle box, so I'm going to have to actually take some of these numbers. Well, 127 is over 90 already, so we can't use that. Okay? But if you take 37 plus that 53, CAB and angle EGF. Sorry, I ran out of room there. It should be EGF. Now you might ask, but hey, no, they're not touching each other here. Remember, complementary angles do not have to be adjacent. They can be non-adjacent, and that's exactly what just happened here. So supplementary angles. Well, we already know if we add these two values, then we are going to get only 90. And so there are a couple different ways you can take a look at this. When we take our angle measurement here of 127 and we add it to 37, well, I already know that the 7 plus 7 is going to be 14. I'm too much here, okay? But if we take this 120 degrees and we take that 53 degrees, okay, so we have 120 plus 53 degrees, 127 plus 53, we're going to wind up with 180 degrees, and that's what your supplementary is. So we can use angle DAC and angle EGF. I left myself room there that time. So again, they don't have to be connected. And we don't know that angle CAF, we don't have any proof that that's a straight line. We have no proof that's a straight angle. So we cannot use, angle CAD and angle DAF because we don't know. There's nothing that tells us that. A pair of adjacent angles. You have several pairs of adjacent angles here. Any two angles that share a common vertex and side. You got right here, these two share, right? You've got right here, ignoring ray GE, you've got CAD and DAF. You've got here EGF and EGC. But we'll keep it simple and look at what's the easiest to see here. Okay, we'll go ahead and look at right here. We're going to be sharing this side, ray AC. So we can have angle BAC and angle CAD. And notice that shared wall between the classrooms, the shared side, is ray AC. All right? The next two vocabulary terms, linear pair. Woo, these are going to be showing up all over the place here. Your definition of a linear pair is two angles whose non-common sides are opposite rays. What does this mean? Look at the word linear, the first four letters, a line. So what this means is it's going to be two angles that form a line. So all we have here is we have a line, and we already saw this with supplementary angles, but they have to be connected. They have to be adjacent, okay? They cannot be disconnected. It's not 180 degrees. What they're saying is they're non-common side. So from this vertex to the left and this vertex to the right create an opposite ray or a line. Your linear pair postulate is just letting you know that a linear pair, they are supplementary. So if we take a look at this one, we said this is angle 1 and this is angle 2, we could come down here and we could say, therefore, the measurement of angle 1 plus the measurement of angle 2 is 180 degrees because it's supplementary, 180 degrees. And that's what we need to use, that 180, to solve when we have linear pairs. So here on this problem, we have our two different angles, okay? We have that line LN and line OP intersect at point M. We can see this. We see that these are both lines. That's how we know that angle LMN is a straight angle, because it is a line, all right? So since we have that line, we can ignore down here, and we have two angles that are right next to each other, angle LMO and angle OMN. They share, they're adjacent, they share, and they create a line. So what we do here is exactly like we do with the supplementary angles. We're going to take one of the angles, LMO, which is 7x plus 20, plus angle OMN, which is 5x plus 10, and set it equal to 180 degrees. This is exactly what you would do for supplementary angles, because linear pairs are supplementary angles. So that's why I didn't do a practice earlier with supplementary, because now we are. All right, let's see. I got a lot of stuff going on. Let me combine these like terms here. All right, very, very important that we get that done. 7x plus 5x, we're going to get 12x. Then when I combine my positive 20 and my positive 10, I'm going to get a positive 30, all equal to 180. Next step, subtract that 30 from both sides. By to the 30 on the left, bring down that 12x. We're going to have 180 minus 30, it's 150. Last step, divide by that 12. The 12s disappear. We're left with x is equal, and we will get a decimal here, 12.5. Now we look back up at the problem. They wanted us to find the measurement of each one of these two angles. So we're going to go in and we're going to substitute in or plug in. I will always say substitute in. So we're going to take that 7x plus 20. Let's go ahead and remove the x, and we're going to place in 12.5. And we're going to find out that the measurement of angle LMO is equal to, when we multiply 7 times 12.5, and then we add that 20, we're going to come out to 107.5 degrees. All right, let's plug in for the other one now. I'm going to move this one down here. We're going to have our 5. We're going to take out x, so then we have our plus 10. We're going to plug in that 17.5. We take 5 times 17.5 plus 10. We're going to find the measurement of angle OMN is equal to 72.5 degrees. And again, you can always go and double check. Does 107.5 plus 72.5 equal 180 degrees? We can double check that one right there. All right. So I know there's a lot of vocabulary, but get your index cards, because we're going on to a couple more words, okay? Or at least one more pair of angles here. Vertical. Vertical angles, right here, are going to be two angles whose sides form two pairs of opposite rays, okay? Let's simplify this. These vertical angles are going to meet at the vertex. Okay, so I want you to remember the vertex, where the vertex is. What this is if we have two angles. Let's say, here we got angle 1, here we got angle 2. Their sides are going to form opposite rays. Okay, they're not going to share a side. They're not going to be adjacent. The reason I want you to think of vertex is because they are across. They touch at the vertex. That is it. vertical angles meet at the vertex, and they're opposite from each other. Okay? And let's say we have this is angle 3 and this is angle 4. We have 4 different angles here and we have 2 lines intersecting, 2 pairs of vertical. What you need to know about vertical angles is they are congruent. Okay, they are exactly the same shape and size, therefore their measurements are equal. So here we can say, okay, angle 1 and angle 2 are congruent. We've learned how to do the congruent markings. Now, if angle 3 and 4 are congruent, we can't just put one arc because that means they're congruent to 1 and 2. So we have to put 2 arcs. Okay? And then with our theorem, we can say angle 1 is congruent to angle 2. Angle 1 and 2 are congruent. And angle 3 over here is congruent to angle 4. They are across the vertex from each other. They meet at the vertex, vertical angles. Very, very easy, nice way to remember that. Okay? Here we have our 2 lines, so we know that we've got straight angles intersecting, so we're going to have some vertical angles. We want to find the measure of angle EBC. So we're going to be looking for this guy right here. We see that these angles meet right here at the vertex, and so vertical angles, their vertical angles are congruent, therefore their measurements are equal. So we set these equal to each other. We have 3x plus 15 is equal to 2x plus 20. When we solve, we need to go ahead and start moving I'm going to move my smaller variable over here. I'm going to subtract that 2x to get rid of it. Subtract 2x. Over here, I have 3 x's. I take 2 away. I'm left with 1x. Bring down the 15. Over here, the 2 x's are gone. Bring down that 20. Then, here, we need to get rid of that 15 by subtracting so they cancel. What we do to one side, we do to the other. Bring down that x, and x is going to equal 5. All right? So we wanted to substitute in for the measurement of angle EBC. So EBC was 2x plus 20. So we're going to remove x, and we're going to replace it with what x is, that 5. And then when we do 2 times 5, giving us 10, we're going to add that 20, right? The measurement of angle EBC will equal 30 degrees. Let's take a look at the next one. Here, it's going to change up a little bit, but you need to know how to do this. We've got 2 lines intersecting, so we have 2 pairs of vertical angles. We also have lines, which is going to help us out in a minute so that we can see linear pairs, supplementary angles. Let's focus one thing at a time here, though. We have that the measurement of angle GIJ. GIJ up here is 16x minus 20. We're then told that the measurement of angle KIH, it's vertical angle, they only touch at the vertex, that's where they meet and say hi. This is going to be 13x plus 7. What's going to change here is I want to find the measurement of angle JIH. Find out where JIH is. JIH. So we're looking for this angle right here. Baby steps. We have a set of vertical angles. They meet at the vertex right here. So we know that these are going to be congruent, so their measurements are equal. So let's set these equal to each other. Solving, whether you want that line or not. First step, let's move a variable. Smaller coefficient over here. I'm going to subtract that 13x from both sides so that the 13x is gone over here on the right. Bring down that 7. 16 minus that 13 is going to give me 3x. And bring down that minus 20. So we got the variables on one side, let's get the constants on the other. So when you get rid of this 20 by adding, doing the opposite, remember? Okay? So you have negative 20, you add 20, you get 0, so they cancel out. Bring down that 3x. We're going to be equal to 7 plus 20 is going to give us 27. Last step of dividing by 3 on both sides. Bring down our x is going to be 9. Now, that's not going to help me find this, because I had nothing to substitute in for. So what I'm going to do instead is remember about a linear pair. Okay, I'm going to bring in a different color highlighter right now, just to make sure you guys can see this linear pair. We have this straight angle, angle KIJ. It is a linear pair. It forms a line. Two angles right next to each other that form a line. A linear pair, as we saw with our previous notes here, linear pair is going to form 180 degrees. They are supplementary. So, if we can find the measure of angle KIH, we can find the measure of angle JIH. So let's find this guy first. So we're going to take that 13, we're going to remove X, and we're going to plug in that 9 for X. We're going to find out this is going to equal 124 degrees. So if this whole straight line is 180 degrees, all we need to do is get rid of this 124. So we take that 180 degrees, that the whole straight angle KIJ, and we're going to subtract this 124. That's going to give us 56 degrees, which is going to be the measurement of the angle that we are looking for. So we're using vertical and linear pair on that. Okay, make sure you understand these words. Make sure that you've got your vocabulary down. Okay.